This section is fitting a line to data. So with this section, we're going to learn how to write a linear model that represents a collection of data points. And with this section, you're going to graph points, but they're not going to be lining up in a straight line. So we're going to try to fit a line that best fits all the data points, and we call this the best fitting line or the line of best fit. So let's look at an example here of what this means. So you may be given a chart with different data points. So this data here on the right says the data in the chart shows the forearm lengths and foot lengths for 18 students in class. They want us to graph the data points and draw a line of best fit that corresponds closely to the data. And then we're going to write an equation of our line. So here we have the forearm lengths and the foot lengths. So when we graph this, this is what the points are going to look like. This is where it's going to fall. So the forearm length, that's representing my X, and the foot length is representing my Y. So when we look at this, 22 centimeters for the forearm length, 24 centimeters for the foot length, what we'll do is we'll graph that. So if you go over to 22 and go up to 24, there's that point right there. If you go over to the next point, 20, 19, there's that point right there. So you're graphing each of these points on a coordinate plane. Then what we do is we draw the line of best fit. So it's going through, the line of best fit is a good range of, notice it doesn't go through all the points, but it goes in the direction of which the points are going. Notice that you'll probably have about the same number of points above the line as you do above. So we have about 1, 2, 3, 4, 5, 6 points below the line, 1, 2, 3, 4, 5, 6 points above. And there's some points that are closer to the line. What we're going to do now is you are going to find 2 points that fall within that line of best fit that we just drew here. Notice they're at the point 19, 20, and at the points 26, 26. So we're going to go through, after we've graphed these points and drew my line of best fit, we're now going to write an equation. So on this next slide, it shows us the steps to do that. So step number 1, we're going to find the 2 points that fall on the line. And that we said on the previous slide was 19, 20 and 26, 26. And we're going to find the slope. Then after we find the slope, then we're going to take the points and the slope, and we're going to find the y-intercept of the line. So to find my slope, remember that's y2 minus y1 over x2 minus x1. So I have here this 1920 would be x1, y1. 2626 would be x2, y2. I'll set that up. y2, 26 minus y1 is 20 over x2 is 26 minus x1 is 19. So when I simplify and solve this down, it's going to be my slope, m, is 6 over 7. Now they did make this become a decimal. We've been working a lot with fractions. For these graphing situations like this, working with line of best fit, the decimal is going to be more helpful when you're finding out the equation of the line, and you'll see why here in a minute. You can use a calculator for this, solving this. So I just want to point that out. So we found our slope, which is m equals 6/7, which becomes a decimal of 0.86. And then for step number 2, we're going to find the y-intercept. So we're going to take 2 points, one of the 2 points, and plug it in. And for this, we're using the first point, just that 1920. I mentioned that in class. So we're going to plug in y, m, and x. So my y is 20, because 19, 20, 20 is my y, equals my slope m, we said that's the decimal, 0.86, times my x value, which is 19, plus my b. So we're going to multiply 0.86 times 19 to get 16.34 equals 20. You're going to subtract 16.34 to both sides. And 20 minus 16.34 is going to give me b equals 3.66. So my final answer written in the equation of the line is going to be y equals, the equation of my line is my slope, which is 0.86x, plus my b, which is that 3.66. And that'll be my answer for example number 1. So notice there are multiple steps here. You have to graph the points. You have to draw the line of best fit, or best fitting line. You then have to find the slope, and then you have to find the y-intercept. So there's technically 4 steps involved with solving these kinds of questions in this section. So along with graphing and finding an equation, we are going to look at some questions here when we're determining the correlation. And think of correlation, think of that as connected to slope. So correlation is when the points on a scatter plot can be approximated by a line. So what you'll see here is positive correlation, and that is a line with representing a positive slope. Negative correlation, it is a line that represents a negative slope. And relatively no correlation is when points are scattered all over the graph. So below here I have some examples of what that looks like. I'd like you to just show an example here so you know, because you will be asked questions like this coming up in the future. So positive correlation, notice there's my scattered plot points. Notice my line of best fit is going through the center. The direction is a positive direction, positive slope, which is the same as a positive correlation. Notice my next set of plotted points here, they're going down, the direction's going down. I have my line of best fit, and this is representing negative correlation, like a negative slope. My last example here, notice that my plotted points are scattered all over the place, and that's what we say that's relatively no correlation right there. So you are going to have questions where they have you look at these correlations and determining whether it's positive, negative, or no correlation. So that is it for this section.